Chapter 5, Part 2, we will continue our discussion on box plots. So the first thing that I want to do is recap what we saw in Part 1, which was when they gave us our 5-number summary, or we calculated that 5-number summary on our calculator, and we used that information to identify if there were any outliers present. Go ahead and pause your video to try this problem on your own, and then I'll show you the work and we'll go through it together. When we are identifying if there are any outliers, we need to calculate our lower and upper fence. I have the two formulas here for you. Remember that with that 5-number summary, you will need to calculate the IQR yourself by taking Q3 and subtracting Q1. After you have that, you can plug everything into your little equations here, and you get your lower fence at -0.5, upper fence at 23.5. At this point now, we will compare our minimum and our maximum to those fences. My minimum is above the lower fence, so it is not an outlier, but my maximum value is above the upper fence, so this maximum would be considered an outlier. You do want to make sure you answer this question in a full sentence, explaining your reasoning. So I said 25, the maximum, is an outlier because it's above the upper fence, which the upper fence is at 23.5. The next thing we'll look at is how to analyze and describe these different box plots. Because box plots still look at quantitative data, we will still use our acronym SOX to describe the shape, the outliers, center, and spread. The same rules apply to box plots as histograms, as stem and leaves, so we'll still kind of use the same ideas with each of these aspects. So the first thing we need to talk about is the shape. There's two things we need to discuss with shape. We need to talk about symmetry, and then we would also talk about the modes. Now, because I have a box plot here, and we're looking at the miles per gallon for different vehicles, you'll notice that I can tell how spread out things are, I can see my box, but there's no way to see different modes here. So whenever you're talking about the shape, you do not need to talk about the modes. Instead, we will just talk about symmetry. Now, if your data was symmetric, the whiskers or the tails on both sides of your box plot would be roughly the same. This one I'm noticing that it does look like this whisker is a little bit longer. So that means my data is pulling towards that one side. Now this one is kind of tricky because it's going vertically. So I would think about this as if you were to take your paper and flip it so that I have my smaller numbers on the left and my larger numbers on the right. Now I can see that that tail is pulling towards the right-hand side, which means that my data here is skewed to the right. So for shape, I'm going to say that the data is skewed to the right. I am going to talk about this in context, so I will say the box plot for miles per gallon is skewed to the right. What's really nice about box plots is they are the absolute best way to show if outliers are present. If there was an outlier present in this data, I would see like a little kind of dot, or sometimes it's an asterisk or an X, something along those lines showing you for sure this data point is an outlier. In this case, my whiskers or my tails extend all the way. There are no like random points here, so there are no outliers present. If there was an outlier present, you would want to take a minute and describe what that outlier is. So maybe I had a dot like way up here at 60. I would then say there's an outlier at 60 miles per gallon. Whenever we're given box plots, we always want to talk about the median for the center because it is nicely given to us in our picture. Remember that the median is that line that's in the, inside of the box. So I'm just going to kind of trace over here to get an estimate, and it looks like that median's at about 23 miles per gallon. So again, we're writing in context in a full sentence. The median is about 23 miles per gallon. Okay, there's two ways that you could talk about spread. You could list the IQR, because again, this is pretty easy to calculate based on our picture, or you could talk about the range. Whenever I'm given box plots, I will always talk about the IQR because that IQR corresponds to your median. Now to find our IQR, what we're doing is looking for the length of this box. We know that this box is always my Q1 and my Q3, so the IQR would be that distance there. So again, we're going to trace across. Let's get an estimate. So I'm thinking that Q3 is at roughly 28, and I'm thinking Q1 is about 17. So if I subtract those, I get 11 for my IQR. So I'm going to say the IQR is 11 miles per gallon. Still touching on every aspect of SOX, so I've talked about the shape, outliers, the center, which again will always be the median, and then the spread, which I recommend always talking about IQR, but you could also list the range. Go ahead and take a minute to try this next example. There's no measures of units, so I don't really know what this is exactly talking about, what this data represents, but take a minute to describe this box plot using SOX. Okay, here is my answer for describing this box plot. A lot of these were kind of estimates, so your numbers may be off slightly, but generally you should have kind of the same description. I said that the distribution or the box plot is skewed left. I knew it was skewed left because it does have this long whisker here kind of pulling towards that left-hand side, whereas the right-hand whisker was much shorter. There is definitely an outlier here. They show you this little X that's representing our lower outlier, and my estimate was that it's around 23. Notice that I don't have any units there because no units were given to me in the box plot. I then listed my median, which was the center line. Again, I'm guessing it's around 55. And to find the IQR, I took my Q3 minus my Q1, and I got around 14. The next thing we'll talk about is how to use these box plots to make comparisons between groups. So we have a histogram and a box plot from the same data here, and this is giving us daily wind speeds. So what's nice if we look at both of these together is that both distributions clearly show that there's a skew, right? I'm noticing that this data is pulling towards that right-hand side, regardless of whether I'm looking at the box plot or I'm looking at the histogram. A benefit of looking at the histogram is that I can see that there's one mode here. There's just definitely kind of one general hump. I can't really tell exactly where the mean or the median would be located. Based on my box plot, I can see the median a little bit more clearly. So what's nice about a box plot is that they offer an ideal balance of information and simplicity. They hide kind of some of those details, but they display the overall summary. So yes, we're missing some of those details, but it's nice that we can still get kind of the overall idea of what's happening. Because they hide the details and explain or kind of show you the big picture, we often plot them side by side when we wish to make comparisons. So here we have a whole bunch of box plots, and this is again showing average, that should say wind speed, not wings, but winds. So looking at average wind speed by month. So instead of just looking at kind of 1 month, we've now split it up into all these different months, and we're able to make a whole bunch of comparisons here. Go ahead and pause your video. I want you to jot down a few comparisons that you could make between these different groups. Whenever we're making comparisons between groups, we still want to think about that acronym SOX and talk about the shape, outlier, center, and spread. But what I think is really interesting is to think about the why. Why are there these differences, or why are there these similarities between groups? So as you look from group to group and we're thinking about the shape, one thing that I'm noticing is that most of the distributions have a little bit of a longer tail on the upper end. So they have a right-hand tail. Most of them are looking like they're skewed left. Some of the distributions are more symmetric than others, like July looks symmetric, but most of them look skewed right to me. So why do you think this is happening? What is making them have that skew? It could just be because there's more days. It's likely that there's 1 or 2 days that have a higher wind speed. Maybe that's caused by a storm that's pulling that data in the higher direction. Another thing you could compare are the outliers. I see kind of some very drastic outliers in November. There's one way up here at like above 8 miles per hour. So what's causing that? Why is there this crazy outlier here in November? Well, what causes wind speeds to increase? A storm. Maybe there was a really, really bad storm in November that caused this one little outlier here. I noticed there's not as many outliers in August through October. Maybe there weren't very many storms there, which is why there's fewer outliers. You could also talk about the center as you're making comparisons. To me, most of the centers are roughly in the same area. Most of my centers look like they're between 2 and 4 miles per hour, so that's kind of a similarity between these groups. And then the last thing you would talk about as you're making comparisons is to think about the spread. In July, there was very little variation. All of kind of my data is tight, close together, and things are not very spread out. Whereas I look in January, and now my box plot is very spread out. I have things ranging from below 2 miles per hour all the way to above 6 miles per hour. So talking about that spread can be very insightful. I don't really know what to expect in January. It could be super windy, it could be not windy at all. But in July, I know what to expect. My data's pretty close together. I'm expecting there to be not too much wind. Here we have an example of 2 box plots right next to one another. It says that the scores of male and female students on a statistics exam are displayed, and the pluses indicate the location of the means or the averages. So I want you guys to take a minute to try and answer this question, and then I'll show you my answer. The correct answer for this should be D. I kind of gave you a little bit of kind of some notes here, so if you didn't get that question right, definitely pause the video, see if you can find your mistake based on my little kind of notes and feedback here. The last thing I want to talk about real quick is re-expressing skewed data to improve your symmetry. When the data is very, very skewed, it can be really hard to summarize them with just simply a center and a spread. If it's very, very skewed, oftentimes that center and spread don't really accurately depict what's happening here. It can be hard to decide whether these extreme values are outliers or are they just part of that skew. So for example, if you're looking here, I have a graph of CEOs and their annual compensation. So I have most of my CEOs making, between 0 and $10 million. But then we've got some CEOs making just a ton of money here. So I'm assuming that this guy on this side is probably an outlier, but I mean, look at all these that are technically outliers based on my box plot. It can be very, very interesting. There's a lot of outliers there. So one way that we could make a skewed distribution more symmetric is to re-express it or to transform the data by applying a log function. In Algebra 2, I think in pre-calc as well, you guys saw this log function, log x. So what this means is that we would take each of our raw data points, we would take the log of it, and what would happen is it would make our data more symmetric. With that symmetric data, it would then be a little bit easier to talk about the center and the spread. We won't get too much into this re-expression just yet, but we will see it later on in our next unit when we talk about scatter plots.